Mustaqim takes on an unusual custom build, transforming a massive used industrial water tank into a fully functional boat for a new customer. But as the cutting begins and the heavy tank is slowly reshaped piece by piece, every stage of the build tests his creativity, precision, and experience, because one wrong move could destroy the entire project before it ever reaches the water. The goal is simple: turn this old industrial tank into something that can actually float. But before the real build can begin, every weak section has to be checked. A few cracks show up along the surface, while most of the tank still holds strong. The damaged plastic is cut away first. Then, the remaining sections are trimmed by hand, slowly turning the old container into usable panels for the boat. Large water tanks like this are usually made from rotationally molded high-density polyethylene, a type of plastic known for being extremely tough and durable. It is commonly reused in marine and construction projects because it handles heavy impact well, resists chemicals, and absorbs very little water. Even after years left outside in the sun, the material often stays structurally strong. He now crafts the wooden ribs that give the boat its final shape. Each one is made in slightly different sizes, allowing the hull to taper gradually from the wide middle section toward the narrow bow and stern. The angled frame and flat bottom profile slowly begin to take form, creating the shallow V design needed for balance and stability in coastal waters. The framework of the boat hull now begins to take shape. In builds like this, every measurement matters because the stability of the boat depends on how weight and buoyancy are balanced across the structure. Even small mistakes can shift that balance, increasing the risk of rolling or tipping once the boat is loaded in the water. That is why simple modular geometry is often used in handmade pontoons and small utility boats. It makes the structure easier to balance, helps spread stress more evenly across the frame, and keeps the entire hull more stable overall. Before the full assembly begins, reinforcement is added at every critical joint. Nothing is rushed at this stage, because once things are locked together, there's no easy way back. Strips of old inner tire rubber are laid along the edges and screw points, acting as makeshift sealing gaskets. It doesn't look impressive, but here it carries real importance. Even the smallest gap could later turn into a leak, and once water finds its way in, it doesn't really stop coming. More rubber layers are added before any plastic pieces are placed on top. Every point where a screw will pass is covered first, sealed off in advance, as if trying to outsmart future failure before it even has a chance to happen. The structure gets marked out and locked into place before any cutting even starts. Everything is checked again and again, because once the blade goes through, there's no undo button here. The side sections are traced out as well, each line drawn slowly, almost carefully enough to feel overdone, but it's not. Pipes are fitted in between the two wooden ribs, bridging them together so nothing can shift or flex out of place later. They're aligned carefully, because once they're set, they're not meant to move again. Then, epoxy is applied, thick and deliberate, locking everything into position as it cures. The bottom part of the hull gets mounted in place, and everything tightens up instantly. This is one of those steps where even a slight misalignment can throw the whole build off, so the focus doesn't slip for a second. It's held, adjusted, and checked again until it finally sits right. Mustaqim starts plastic welding using leftover plastic gathered from drilling waste. Nothing is thrown away here. It all gets collected and fed right back into the build. He melts the material down and fuses it directly into the structure, working it in layer by layer. Once everything is smooth enough, wooden angle bars are placed along the edges. It's not just for finishing, it's protection. These bars cover the welded seams, shielding them from impact, from flex, from anything that could cause a crack later on. Building a DIY boat is never just about making something float. If it were that simple, almost anything could be pushed into the water and called a boat. A build like this has to balance everything at once. Buoyancy, waterproofing, and weight distribution. Every small decision affects something else, and mistakes usually don't show themselves until the boat is already in the water. At the center of it all is a simple rule. The boat has to displace enough water to carry its weight. Not just the hull, but passengers, fuel, tools, the motor, everything. The moment that balance is off, problems start building fast, and water is unforgiving. Mustaqim mixes the two components of rigid polyurethane foam in equal ratio and quickly pours it into the hull before the reaction starts to kick in. Almost immediately, the foam begins to expand. It starts slow, then suddenly picks up speed, crawling through the structure and pushing into every hidden gap it can reach. Deep inside the hull, it spreads into compartments that would be impossible to fill manually. As the reaction builds, heat starts to form inside the foam while it gradually hardens. What begins as a liquid turns into a dense internal core, locking itself into the structure from the inside out. And once the expansion starts, it doesn't stop until every available space is taken. As the foam keeps expanding inside the sealed cavities, it stops behaving like a simple liquid spread. Instead, it forces its way along the easiest paths, pushing deeper into tight corners and narrow gaps. In rigid polyurethane systems, this stage is known as progressive fill pressure, where the expansion keeps going until all internal voids are fully filled. Inside the hull, steady pressure of the expanding foam tightens everything up, pressing each layer firmly into place. At this point, the shape of the boat isn't defined by wood alone anymore. It's being held and stabilized from the inside out by the foam as it expands and locks the structure together. This is why polyurethane foam is so widely used in buoyancy systems. Once it cures, it forms a closed cell structure, tiny sealed gas pockets trapped inside rigid walls. It stays light, resists water, and holds its shape even under pressure. But its real value isn't just flotation. As it expands and hardens, it ties the internal structure together, adding stiffness and turning separate sections into one reinforced body. There's a common misconception in DIY boat building that flotation foam makes a boat float higher. It doesn't. The hull is what provides buoyancy. The foam only becomes important when something goes wrong, when water starts entering the boat or the hull gets damaged. That's when it takes over, filling empty spaces that would otherwise flood. And instead of letting the boat sink completely, the foam slows everything down, holding enough trapped volume to keep it afloat. That's where the idea of an unsinkable boat really comes from, not because it never fails, but because it refuses to go all the way down when it does. Meanwhile, the rear section gets reinforced with a transom reinforcement pad. It's added directly onto the back panel, thickening and strengthening the area where all the load will concentrate. This isn't just extra material. It's a critical support point. It has to handle the full weight of the outboard motor. As for the internal surface, marine-grade plywood is used as a sheathing layer fitted inside the completed frame structure. It works as an internal skin, reinforcing the inside, sealing the surfaces, and adding another layer of stability to the structure. In reinforced DIY builds like this, it helps tie everything together, turning the frame into something more rigid, more sealed, and more resistant to movement over time. At this point, the hull is already defined by the wooden frame and internally reinforced with plywood lining, but there are still hollow spaces between the structural members. Mustaqim begins pouring a foam mixture into all accessible internal cavities. The key here is complete coverage, because if even a few pockets are left unfilled, water can find its way in later. One of the most reliable signs that all cavities are fully saturated is foam overflow. It's not just leftover material spilling out, it actually tells something important about what's happening inside. In practice, that overflow becomes a simple but effective indicator that the hidden voids inside the hull have reached full capacity and the structure is properly packed from within. In marine work, sanding isn't just finishing, it's called fairing. It's the process of smoothing everything into one continuous surface, removing sharp transitions, waves, and imperfections that would disturb how the hull moves through water. When a metal structure is added for a tent or canopy on top of the hull, the build becomes much more sensitive. In marine design, anything added above the deck is considered topside weight, and that weight matters. It changes how the boat sits in the water, how it rolls from side to side, and how easily it can become unstable if the balance is pushed too far. After washing and drying, the surface is prepared for finishing. An epoxy-based coating goes on first, sealing everything against moisture and locking the surface down. Then a primer layer is applied, helping the paint spread evenly and bond properly. Finally, the whole surface is finished with marine-grade paint, giving it protection from water, sun, and constant exposure once the boat is in use. In small boat design, seating isn't just about comfort. It actually affects how the boat sits in the water, because every passenger adds to the live load. So, before anything gets fixed in place, the seat positions are planned carefully along the hull. The weight needs to stay centered along the keel, not pushed too far to the bow or stern, and it has to be balanced evenly from side to side. At the same time, there still has to be enough space inside the boat so people can move without messing up that balance. In small marine craft, a tent or canopy is usually treated as a soft superstructure. It doesn't help the boat float, but it makes a big difference when it comes to comfort, protection, and how usable the boat actually is. Height, width, and every angle of the metal structure are carefully measured and translated into fabric patterns. Nothing is guessed here, because even a small mismatch shows up later when the fabric is under tension. In fabrication work, extra margin is always added to the pattern. The material needs that little bit of allowance so it can be stretched, adjusted, and pulled tight during installation. That extra space is what helps the canopy sit clean, stay tight, and end up properly sealed against wind and water. The tent material has to handle constant exposure to harsh conditions, sun, rain, and strong wind without breaking down over time. That's why coated synthetic fabrics are used, like PVC-coated polyester and other waterproof textiles. In outdoor engineering, these aren't just normal fabrics, they're technical textiles, built specifically for long-term exposure. The canopy affects how the boat behaves in wind and motion. It adds wind resistance, almost like a sail, and increases sideways pressure during strong gusts. It also slightly shifts the balance above deck and adds weight higher up. In naval terms, this is called windage, the effect of above-deck structures increasing wind exposure and influencing stability and control. The boat is no longer just an open hull, it has become a complete floating shelter system. Everything has its role now. The hull keeps it afloat and holds the structure together. The foam adds extra buoyancy and rigidity. The seats turn empty space into something usable, and the tent wraps it all up, shielding it from sun, wind, and rain. And now, the finished boat stands as a fully assembled floating system, a lightweight but stable platform on the water. At its core, it's a practical hybrid build, where recycled industrial materials are turned into something functional, structured, and ready for real-world use on the water. From raw materials to a finished creation, this is just one story. Subscribe to Mustaqim and be part of the next one. Your ideas might shape what we build next.